Imagine standing at the edge of a quiet river just before sunrise. The water is perfectly still. Then, without warning, two ancient eyes rise above the surface. They belong to a creature whose ancestors watched continents drift apart, survived global catastrophes, and witnessed the rise and fall of entire worlds. Now consider something even more astonishing. The mighty Tyrannosaurus rex disappeared forever. The towering Triceratops vanished. Countless species that dominated Earth for millions of years were erased in what geologists call one of the greatest extinction events in our planet's history. Yet crocodiles survived. How could an animal that seems almost unchanged today outlive creatures far larger, faster, and seemingly more successful? Was it luck, evolution? Or did crocodiles possess something that dinosaurs never had? The answer isn't hidden in a single moment. It's buried across hundreds of millions of years of Earth's history. To understand why crocodiles survived when dinosaurs didn't, we have to travel back to a world that looked nothing like our own. About 250 million years ago, life was recovering from the worst mass extinction Earth has ever experienced. More than 90% of marine species disappeared, while ecosystems on land collapsed almost completely. The planet was scarred, unstable, and strangely empty. Among the survivors emerged a group of reptiles known as archosaurs. These weren't dinosaurs, not yet. Instead, they were the common ancestors of both dinosaurs and crocodilian. At first glance, they probably looked fairly similar, but over millions of years, evolution pushed them in very different directions. One branch evolved into increasingly agile animals. Their legs moved beneath their bodies instead of sprawling to the sides. Many became faster, taller, and more specialized. Eventually, they gave rise to the dinosaurs. The other branch took a different path. Instead of becoming faster runners, these reptiles experimented with many lifestyles. Some walked on two legs, others resembled wolves, armadillos, or giant predators. Ancient crocodile relatives were astonishingly diverse, filling ecological roles that modern crocodiles no longer occupy. This is the first surprise. The crocodiles we know today are not primitive leftovers frozen in time. They are the last survivors of a once enormous evolutionary family tree. Their ancestors changed dramatically over millions of years, adapting again and again as environments transformed. Many of those ancient crocodile relatives disappeared long before the dinosaurs did. Only one particular strategy would ultimately prove nearly unstoppable. As dinosaurs expanded across the planet during the Jurassic period, they became the dominant large animals on land. Gigantic herbivores crossed floodplains. Massive predators hunted them. Flying pterosaurs ruled the skies, while the oceans teemed with marine reptiles. Compared with these spectacular giants, early crocodilians occupied quieter roles. Many lived along rivers, lakes, swamps, and coastal wetlands. It might have seemed like second place, but evolution doesn't reward the strongest. It rewards whatever survives. For millions of years, crocodilians refined a remarkably efficient design. Their bodies became low to the ground, reducing energy demand. Their tails developed into powerful swimming engines. Their eyes and nostrils shifted to the tops of their heads, allowing them to remain almost completely submerged while watching the world above. Perhaps most importantly, they became masters of patience. Unlike mammals and birds, crocodilians don't need to burn enormous amounts of energy every minute simply to stay alive. As ectotherms, they rely heavily on external temperatures to regulate their bodies. This means their daily energy requirements are dramatically lower than those of similarly sized, warm-blooded animals. A large mammalian predator must hunt frequently. A crocodile can eat a large meal and survive for weeks or even months without another. That difference doesn't seem dramatic during good times. It becomes everything during bad time. Then came the day that changed Earth's history forever. About 66 million years ago, an asteroid roughly 10 kilometers wide slammed into what is now Mexico. The impact released more energy than billions of nuclear bombs. Shockwaves circled the globe. Wildfires spread across continents. Molten debris rained from the sky. Then came something even worse. Dust, soot, and sulfur compounds filled the atmosphere. blocking sunlight. Temperatures dropped, photosynthesis nearly stopped, food chains began collapsing from the bottom upward. Plants died. Plant-eating animals starved, predators followed. This wasn't simply a bad year. It was a global ecological breakdown that lasted for years and triggered one of Earth's 5 great mass extinctions. Nearly 75% of all species vanished. So why didn't crocodiles disappear too? The answer wasn't because they were stronger. It was because they were prepared for exactly the kind of world that suddenly appeared. Imagine 2 predators. One requires thousands of calories every day. The other can dramatically slow its metabolism, remain inactive, and survive on stored energy for extended periods. Now remove most of the food from the planet. Which one has better odds? Research suggests crocodilians could drastically reduce their activity, conserving precious energy while waiting for conditions to improve. Many likely spent long periods in water, mud, or sheltered environments where temperatures changed more slowly than on land. Even more importantly, aquatic ecosystems didn't collapse as completely or as quickly as many terrestrial ones. While forests disappeared, rivers and wetlands continued supporting fish, amphibians, crustaceans, and other aquatic prey. Resources became scarce, but they didn't vanish entirely. This gave crocodilians access to food when many land predators had none. Then another remarkable advantage appeared. Crocodilians are among nature's least picky eaters. Modern species consume fish, turtles, birds, mammals, reptiles, insects, shellfish, and carrion. They scavenge whenever opportunities arise. An animal that insists on one food source faces disaster when that resource disappears. An animal willing to eat almost anything gains option. During a global extinction, options mean survival. But perhaps the greatest secret of crocodilian success has nothing to do with teeth. It's about flexibility. Evolution often celebrates specialization. Cheetahs evolved for incredible speed. Koalas specialize in eucalyptus. Giant pandas rely heavily on bamboo. Specialists thrive when conditions remain stable. Generalists survive when everything changes. Crocodilians became extraordinary generalists. Freshwater rivers, saltwater estuaries, tropical wetlands, coastal lagoons, different prey, different climates, different water conditions. Their bodies weren't optimized for one perfect environment. They were good enough in many. That adaptability became priceless after the asteroid impact reshaped Earth's ecosystem. Yet survival didn't mean life became easy. Many crocodilian relatives still disappeared. Entire evolutionary branches vanished forever. The crocodilians alive today descend from only a fraction of the diversity that once existed. Even the winners barely escaped. Millions of years passed before ecosystems fully recovered. As forests returned and mammals diversified, crocodilians continued occupying aquatic environments where they faced relatively little competition from the rapidly evolving mammals. Then came another unexpected twist: birds. At first glance, birds and crocodiles couldn't seem more different. One flies through the sky, the other lurks beneath murky water. But genetically, birds are actually the closest living relatives of crocodilians. Both descend from ancient archosaurs. In a sense, dinosaurs never completely disappeared. Their avian descendants still surround us today. Every sparrow, eagle, and hummingbird carries part of that ancient dinosaur legacy. Meanwhile, crocodilians represent the surviving branch of their evolutionary cousins. Together they form the last living representatives of a world that existed long before humans ever appeared. As Earth's climate shifted repeatedly over tens of millions of years, crocodilians continued changing in subtle ways. Modern crocodiles are not identical to their ancient ancestors. Their skulls evolved, their immune systems adapted, their behavior refined. Even their genomes continued changing. To human eyes, they appear ancient because their overall body plan has remained effective for an extraordinarily long time. Biologists sometimes describe this as evolutionary stability. When a design works exceptionally well, natural selection has little reason to reinvent it. Sharks display a similar pattern. So do horseshoe crabs. This doesn't mean evolution stopped. It means evolution kept improving an already successful blueprint instead of replacing it. There's another characteristic scientists increasingly admire. The crocodilian immune system is remarkably powerful. Living in warm, bacteria-rich water exposes these animals to constant infection risk. Yet crocodilians often recover from severe injuries that would prove fatal for many other species. Their immune defenses are unusually robust, allowing wounds to heal despite living in environments filled with microorganisms. Although no immune system could have prevented the asteroid impact, resilience like this helped crocodilians endure countless everyday challenges over millions of years. Small advantages accumulate, generation after generation, until they become the difference between extinction and survival. Today, crocodilians inhabit tropical and subtropical regions across several continents. Some species thrive in freshwater rivers, others tolerate full-strength seawater for extended periods. The saltwater crocodile can even travel across vast ocean distances, colonizing islands and coastlines separated by hundreds of kilometers. This ability to disperse has allowed crocodilians to reach new habitats whenever environmental conditions changed. Again, flexibility proved more valuable than perfection. Ironically, after surviving asteroid impacts, ice ages, volcanic eruptions, and dramatic climate shifts, crocodilians now face perhaps their greatest challenge: us. Habitat destruction, pollution, illegal hunting, and climate change threaten many populations. Several species remain endangered despite their incredible evolutionary history. Their survival is no longer determined only by natural selection. It increasingly depends on human decisions. That realization changes how we should see these animals. A crocodile isn't merely a dangerous predator resting beside a river. It's the product of more than 200 million years of evolutionary experimentation. Its ancestors survived disasters that reshaped life on Earth. Every scale, every tooth, every silent movement through the water represents solutions refined across unimaginable spans of time. So why did crocodiles outlive the dinosaurs? Not because they were bigger, not because they were more intelligent, not because they escaped the asteroid. They survived because evolution had equipped them with traits perfectly suited for catastrophe. They required little energy, they could endure long periods without food. They exploited aquatic habitats that remained relatively productive. They ate almost anything available. They adapted instead of depending on a single way of life. In a stable world, those qualities may seem ordinary. In a collapsing world, they became extraordinary. The extinction that ended the age of dinosaurs wasn't a contest to determine the strongest species. It was a ruthless test of resilience, and resilience won. The next time you see a crocodile lying motionless beneath the sun, it may look like it's doing almost nothing. But that stillness tells one of evolution's greatest stories. It's the stillness of a survivor, a living witness whose ancestors watched the end of one world and quietly endured long enough to enter another. Long before humans imagined history, crocodiles had already mastered the one lesson that matters most in evolution. The species that lasts isn't always the fastest, the largest, or the fiercest. It's the one that can keep going when everything else changes.